So this activity is going to be conducted in English because we have some guests here from Europe. Thank you very much for coming to the school, to the Escuela de Sistemas Informáticos en el Campus Sur. I'm Jaime González. I'm Associate Professor in Business Management. These days we are hosting here a workshop from the ELISA program. It's about researching on sustainable business models and create value for stakeholders. And we have some visitors from Santa Ana, Escuela Superiore Santa Ana, from Pisa, Friedrich Alexander Universität from Nuremberg in Germany, and the Istanbul Technical University from Turkey. So we are here all together. And this event is going to take for 2 hours, more or less. We have two very good speakers, keynote speakers today. They are Jan-Nicola Scarpa and Espen Pedersen. It's going to be the second one. And Jan-Nicola is an associate professor here in this school. He got his graduation in computer science in 2009 in Salerno. He was a PhD student in Amsterdam. I will try to say the name. It's Centrum Wiskunde and Informatica.
Perfecto.
Thank you. And postdoc at the Universidad Autónoma de Barcelona and Universidad Complutense de Madrid. And now we are lucky because you are here.
Or not.
Let's see. Okay. Thank you very much. The floor is yours.
Thank you very much, Jaime, for the invitation. I am very happy to be here talking to such a broad, diverse audience. It's one of these rare occasions where finally you have, no pictures please, finally you have somebody which is part of your target audience, part of the people you would like to reach. Okay, so, and these are PhD students in other fields or in other areas of computer science, and international researchers in the area of economy. So first, let's spend a second recapping my direction. I've been in all these places. I started in Salerno studying computer science. Then I went at Sbrw Amsterdam working in theoretical computer science. There I learned quantum computing. I was already interested since then in game theory, which is part of decision theory. This one cannot be. No, of course, it doesn't display on a real display. Fantastic. So it's part of decision theory, and so quantum computing has application in the way people make choices, in analyzing. And now we will show you a bit what I mean by that. During the years later, I stirred to different topics in quantum computing. Of course, you need to make research, you need to find interesting problems to work on, but I still always had this idea in mind. And I was working just last week, with a colleague of mine on solving a problem similar to the one I'm going to show you. And she said, but Gianni, we have this huge book on game theory. Isn't there a book called Quantum Game Theory? And I said, no, but there are 2,535 publications on quantum game theory. None of them follow, few of them follow exactly what they should. Follow the techniques and the topics properly. So I felt a bit entitled to say so, because I've reviewed and read many of them. Not all 2,000, but at least 50, 60, and I see the pattern arising all the time. So now that I'm here with you, let's go first on a little journey on what quantum computing is, but not really technically, because I don't want to bore you with technicalities. Let's see the meat of the problem, how can you use quantum computers? So, quantum computers. They look like this, actually. This is a prototype by IBM. And of course, it's nicer when you open it because it's full of little wires and stuff. It is basically I mean, like, they probably watched too many sci-fi movies, and they made this thing looking like HAL 9000 from Space Odyssey. But it's really a microscopic chip in a giant fridge, right? It needs to be close to the absolute zero, and there is a little chip with, like, I think this one has 2,000 like atoms that work together to actually perform a computation. And you can program it, they have a nice web interface, and you can send things to it. Problem is, it's not very close to absolute zero, and the solution are still very noisy. But IBM promises to be the revolution here, and promises to make it better and better every year, so that finally we'll get a full error-free quantum computer. So they say, and many companies say, that it has powerful computational speedups for the following problems. Well, no problems, okay? So there are no problems for which we have a provable speedup, and that's because of these people. These people, like, of which there is a very close collaborator of mine, and what they show in this paper, if you read the last thing, is that they have a method, a numerical method, to simulate all current quantum computers and all the future quantum computers up to an infinite number of qubits, if the computers are made the IBM way. IBM is trying to, like, make a computer that works, blah, 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 and uses some constraints on the thing. It's like, okay, not all qubits can interact with all the others. It's not really universal, but maybe it works. Yeah, they have proven that it doesn't. This is from 2023, December 2023. But even before that, there was no demonstrated computational speedup. It normally works like that. IBM or Google, which I have the mark of the beast on me, they claim that, our computer has solved something, and no classical computer can solve it, no standard one. Wait a week, and somebody clever codes something in a laptop that does the same. And okay, so this is the cat and mouse game where millions have been invested, and some smart people can just make them useless. But I'm not here to give a negative talk. I'm here to let you understand what is actually the feature to look for in quantum computation. And it's not pure horsepower. People always present this thing, I do not know why. It's culture, it's like, marketing ideas, but people always say, quantum computer will be so fast that will revolutionize the way you solve problems. They will probably revolutionize the way you solve problems, but not because they are faster. They are faster theoretically in a very restricted range of problems, and where they are really faster is not much of a difference. It's only a polynomial factor. There's few problems where you know that exponential factors, and that's because we don't know well how to solve this problem normally. But okay, so what is more? The first thing that quantum computers can do that is impossible in normal computers is create entanglement, which normally is like described in a way that I don't like. Is that like, two particles can talk to each other faster than light? Well, that's not really true. If you read about the entanglement, the correct definition is that quantum systems, some of them, can only be described as a whole, right? Not as a sum of their parts. So you see description of part 1, description of part 2, you don't have the full picture. It's a bit like it happens on this image here. If you look at the left side, you see a face, and the right side, you see another face, but only when you put them together, you see that they form a base. Okay, so there is some extra information. Of course, that's not entangled, but okay, you get it, right? Okay, so that's something. So people normally say quantum bits can fall in love and show pictures like that, when there's a link between two two photons or two atoms. Well, in reality, quantum system, although separated in space, can behave as a single system. We'll see later a better way of saying this. Okay, but this is something that you can use, and you don't even need a quantum computer for doing so. You just need a quantum communication device without full-fledged computation abilities, and you can already use that. You can actually buy quantum communication devices which work with very little error commercially. There's people who sell them for €1,000, €2,000, there's a Swiss company especially that does that. And so people can start experimenting now. Okay, and what does entanglement do? Well, it creates something called non-locality. Highly correlated behaviors that seem impossible. And sometimes these are described as quantum pseudo-telepathy, and this is true. It's like there is something in theory, it's like, oh, this is an example of a pseudo-telepathy game. It's a game in the sense of game theory where players can show behavior which seems like impossible in our normal things, like it's as if they had communicated, but they haven't. Okay, so you can imagine these two people shuffling the cards and ending up with the same order, right, in two different places. It's actually the same person, I just reflected the image because I'm lazy. So, uses in physics of this. So, actually, game theory and this kind of games where people can share quantum states and they get questions, they need to answer. In game theory, you would say they have a type, they perform an action. They're used in physics to make experiments that check that reality is not described by classical physics but by quantum. Actually, this is the only way they managed to prove it. It doesn't matter that quantum mechanics predicts effects that classical cannot, because maybe there is a way to explain it classically. These kind of experiments show you that somebody can perform something and they can win a game, they can succeed in an experiment that would be impossible without entanglement, and that impossibility that this time is proven. And so they normally work like that. Somebody making questions to two people, right? And these two people cannot talk to each other, but they can share entangled state, and then they answer. They read their entangled state and they answer. You can see that they could not communicate because the questions happen very fast, very instantly, right? Almost at the same instant, and the answer needs to come fast, so they don't have time to communicate. They don't have physical time to communicate. So this idea and a simple game in the game theoretical sense was object of the 2022 Nobel Prize in Physics. So I have a personal record, so if you want to know my research, so when I started the PhD, I designed a game in the sense of game theory. I studied a bit of game theory, I studied a bit of computer science, and I said, okay, how can you make the quantum classical difference grow a lot with the number of qubits involved in the experiment? And we figured out that there was some upper bound, right? And that we managed to match it with an explicit game, like, oh, you do this, you do that, oh, the objective is this, okay? And here you see that, for example, here I plotted the difference, that classical players cannot do better than the blue line, and quantum players can do a lot, and a lot better, and the performance grows with the number of qubits. You will need like 2,000 qubits to see a very big difference. That's why we haven't done the experiment in practice. But it's a big brother version of the kind of experiments that I was saying before. So game theory has been used to single out the property of quantum physics. Okay, but it didn't stop there. Like when you describe things as a game, and again in the economy, game theory kind of sense, then you can start saying, oh, there is a bad player who wants to cheat, no? And you can use all of these things as in security. So games are used to model random number generation. So you have somebody wants to generate a random number, and somebody else wants to figure out what the number is, and you can actually prove that if you use quantum devices, true randomness is extracted from nature. And there is even more. This randomness cannot reside in the device. So you don't need to trust, I don't know, Xiaomi or Samsung or whatever that they did a correct implementation, right? So you can use whatever brand, and you know that the random numbers that you generated came from nature, were extracted from outside the devices. So they couldn't be predetermined, they couldn't be copied, whatever. So all of this is done through things, so through game theory. So we can also use game theory in quantum to solve difficult problems. For example, graph coloring. I don't know if some of you are familiar with graph coloring or with this kind of problem. Graph coloring is a master problem. It's one of the problems that if you solve it, you solve all difficult problems in a certain class. Okay, and normally people struggle to find an algorithm and stuff. Well, there is a way of, and this was the object of my PhD thesis, of expressing this as a game, where now we have two players who are painters, and they get given two inputs. Hey, how would you color these two things? And these things are chosen at random, and they need to say a color. Well, this had very good properties, because we could use it to, say impossibility results for some certain graphs. If you cannot do it this way, you cannot even do it the normal way. And of course, it told us how to do things more optimally for problems such as, hey, I have two frequencies in the spectrum, in the radio spectrum. I have two cell phones who want to use it. Where do we allocate the first one or the other? Well, frequency equal color, and you can use these kind of things. Right, so when there is an on-the-fly choice to be made, there are some situations where we can be much smarter. And again, designing it as a game, using tools from game theory and using tools that theoretical economists are familiar with. So then we said, okay, well, why don't we do things in society? And this is a cartoon that I made for a poster, where we show more or less what is a problem that could be tackled by quantum computers, right? So imagine you have two agents that want to coordinate, but they still have a secret type, right? They're like, I don't really want to know some things about my trade. That could be an objective, that could be a secret ingredient, or could be something. Well, you can use a mediator that takes their type, which is their secrets, and takes both of them and promises to correlate them in a certain way, so that the advice given will not reveal such secrets, and still you have better coordination. Right, we have several examples of this, like in choosing the roads, or in scheduling appointments and stuff like that. But the important thing is that quantum technology could get rid of the advisor. So you could get this kind of correlations and be more coordinated than without this device, and still guarantee that the other person doesn't learn your secrets, whatever. So they can save money or resources, right, and keeping their own trades. Okay, so how do you do that? This finished, but how do we achieve it? Well, we need some means of quantum communication, and this is the quantum internet. This is the famous paper for the people in the area in Science, where they lay out the vision for what the quantum internet will be. And I really show you this paper. I mean, look for quantum internet science paper by Stephanie Werner and other people. This really lies down things realistically. So it contains one roadmap of where we are currently here, probably. So we haven't implemented yet any of these things, but as soon as one of these technology becomes available, there is already an application, right? And you know, so these applications are taken from the literature. There are excellent references there, and you know, so whenever a company tells you, "I will give you quantum computing in 10 years," please buy it so you can apply it in your thing, or collaborate with us. Well, let's make something. Well, your answer should be, "Can I have a trusted repeater instead?" And maybe in 2 years, and they say, "Oh, probably they cannot do that." Okay. So this is exactly what to expect, and this is the main message I wanted to give you. Quantum computing is difficult. There is a lot of overclaiming, and I dare anybody who wants to disprove me, I will accept it, but there's nobody who was able to prove that the computer can do something. Okay, and so what we're concentrating now is quantum communications. There are little devices that can communicate now quite well. However, there's no repeaters for a reason that is technical. Right? When the repeaters could be implemented, then you can communicate with anybody on the internet. Okay, but for now, there's only fixed links. The UPM, actually, the Polytechnica, is trying to be part of one of these links and to start building a quantum internet. So they are actually working on quantum repeaters, but not in this faculty, in the good one. So, which is the other computer science faculty. So, okay, more mainstream applications for you. Did it get recorded? Oops. More mainstream applications for you. So, optimization. Simulation of physical systems, such as protein folding or stuff like that. Saving on energy. Okay, all of these things have been tried with quantum computers. Problem. Yeah, okay, sometimes it's good to have a different implementation, just because it's different. It's like sometimes you approach a problem from another point of view, even from a different field, right? It's like, oh yeah, let's think as an economist, or let's think as a mathematician, right? And you get connections and you get insight in the problem. So it's good to study how to do optimization with quantum computers. It's very good. It's good to simulate physical systems with quantum computers. And all of these things can be simulated by the papers I've shown you before with current technology. But maybe if the technology evolves and we get beyond the approach that IBM and company are doing, maybe we can start see some difference, right? Also, and the saving of energy, I highlighted it not only because we are in a sustainability workshop, but because that's kind of something that doesn't need much innovation. Like there are some quantum computers now, which however noisy, however bad, however slower than your laptop, they consume very, very little energy to do the same task. So for example, if you want to train a neural network model or train something, yes, you could try and do it with that. Just to see like, okay, maybe overall we're saving energy. They need lots of energy to cool down. That is true. But once they are cool, quantum computers works on a zero energy fashion. So they don't consume energy because they don't lose bits. Quantum bits cannot be deleted, unlike classical bits. And when you do classical computing, there's always that thing, n bits of input, process, 1 bit of output, the result. Or like, you have A times B equals C. But what happened to B? Or what happened to the space that B was occupied? Oh, it gets deleted in the circuit. How does it get deleted? Heat. Energy dissipation. And quantum computers don't have that. They're always reversible computation. So somehow you can always go back. So they always keep all the information. They only shuffle it. They only permute it somehow. And that saves lots of energy. So zero energy computation can be done with quantum computers that are now available with lots of noise, with lots of loss. But it's a thing to think about. And now my question, are we ready for all of this? Industry and academia is always one step ahead of of everything. We always try to find applications, applications, applications. Why? Because our society drives us to that. People in our society the government doesn't give us money if we don't do applications. I give applications to my research as an excuse. Please give me money, we'll use it this way. We never do. But we prepare, that's true. We prepare things for the future, and of course what I do probably will have an application, I get papers lying down there since 10 years, and suddenly somebody uses it in an unexpected way, which is something so brilliant to see. Wow, somebody used my paper. Oh my goodness! And what did they do with it, right? But if you think about it, Euler was studying modular arithmetic and all these things 250 years before modern cryptography was invented, which uses Euler's theorem and Fermat's little theorem, which had nothing to do with cryptography. But how could they know? They just wanted to know what happens in finite fields. Sorry, those were mathematicians. So are we ready for all of this? Are we ready for the technology? Are we using it too fast without knowing what we do? My answer is yes. We are maybe not really understanding what we are doing, and maybe we are embarking in a dangerous thing, as it happens with AI. If you put people do AI, now there was the news 2 days ago of an AI input injection attack that was done to a company. Somebody in the internet, gave an input to an AI that did bad things to the database of the company. Fantastic, that's the next level SQL injection. Okay, I cannot do it directly, let the AI do that. And so basically, putting this, a Canadian company, Air Canada, got sued because their AI promised a discount to somebody. And they didn't do the discount to somebody, so they said, hey, where's my discount? Your assistant told me. And the next time you put a person there, and this will not happen. And they had to pay. They had to pay. So are we ready for, we're not ready for AI, that we know. But are we ready for quantum computers? Well, I really want to convince you that we are not. Let's go back to the basics, okay? Let's take, we have a bit. So in principle I can finish at 1, but then I need to teleport to the Complutense, so I'll try to finish in half an hour. Okay, so, you with me? Okay, I want to do a little, teeny, tiny experiment with the audience. So please drop your computer, drop your WhatsApps and everything, and stay with me for a second. Look at either of the screens, okay? I count to 3, and we say out loud in English what we see, okay? 1, 2, 3.
Star.
Muy bien. Okay, very good. We saw a star.
Of course.
Of course. Other comments? Other comments there? It's clearly a star, right? What else can it be? Well, take somebody from the depths of the Amazon forest in Brazil who has never had contact with the outside world, like there are some protected tribes. Show them this. Do you expect them to say it's a star? And why?
Because it's not a star.
Because it's not a star, but why do we think it's a star? First of all, let's see if this is correct. Okay. Goodness. Yeah, this thing always takes me sometimes, It has been taught to us, right? We've been taught to us, right? Very good, very good. So, education. Education creates something which is, in economy, is called a common prior. Have you heard of that? A common prior, right? So we have a common prior. We use this common knowledge that we have, even with such distinct nationalities and basic educations. We all know it's a star, and we think that everybody knows it's a star. I mean, people who were doing things for the Voyager thing, like Carl Sagan, at some point after sending the Voyager thing, said, wait a second, in the drawing we did with the two humans say hi, and with the stars, we put an arrow towards the Earth, right? Said, yeah, we put an arrow towards the Earth. How are the aliens, like, gonna know what an arrow is? They don't have arrows. And, oh, but they sent it, so it was too late. So, common prior. Well, they could go and recover it. Voyager, come back, right? Or they would send Voyager 2 with like, actually that's what's an arrow, right? So, errata. Okay. So we receive similar education, we formulate a statement based on the similar education. We know that others share backgrounds with us and will reach similar conclusion. We know that they know the same thing about us. We know that they know that we know that they know the same things about us. We know that they know that we know that we know that they know the same thing about us, so on forever. This is called common knowledge. The fact that this is a star is common knowledge, and it's studied in epistemics. Epistemics, people who need to do the test, not down. Epistemics is the formal study of knowledge, not to be confused with epistemology, which is the philosophical study of knowledge. And in epistemics, everything is mathematical. And we base our current life, our current studies, and everything on these concepts. Like in the 1970s, pioneers such as Robert Aumann and Ashani, other economists, were really drawing the basics for that, to study the markets, to study why there are markets, why there's equilibria, and why why things work in general. And of course, you can use it for sustainability, just for the record. But we all lie down on this concept of common knowledge. I'm going to break this concept for you, okay? So, this is Robert Aumann's agreement theorem, which got him a Nobel Prize. Okay, so what he says is that two agents who share a common prior cannot agree to disagree. It's not possible that any of you will say, this is not a star, and somebody say, wait a second, what do you mean it's not a star? And conclude, oh yeah, you're right, this is not a star, but also you are right, this is a star. That's not possible. If you share a common prior, we all need to agree that that was a star. So how do you do it formally? I don't want to be too much formal, but a little bit. I can't do things without mathematics, I feel naked. So what you do is the following things. You have a set, in this case omega 1 up to omega 5, of states, possible states of the world. Okay, so states of the world are simply what describes your environment of interest right now. Right, and they say, oh, this could be the case, this could be the case, this could be the case, this could be the case. Everybody has a prior probability distribution over states of the world. This could be the case, yeah, but with which probability? On this one, we agree. Okay, so this is a starting point. If we do that, then agent A and agent B can have different partial information. This is the Aumann's incomplete information formalism. Okay, so there will be a true state of the world sampled at random with that prior probability. For example, say it's omega 3, and Alice will know that the true state of the world is in the second partition here, the blue one. It's either omega 3, omega 4, omega 5, and Bobby here will know that is either omega 1, omega 2, omega 3. Okay, so Alice and Bobby have partial information. And so they can actually start reasoning about that and say, okay, now take the event in yellow, omega 3, omega 2, omega 4. What's the probability of it? What's the posterior probability of it, given our prior and our partial information? Well, they can definitely reach different estimates, right? Because see, the intersections here are different, the probabilities are different, so they can disagree. Aumann's theorem says that if their estimates are common knowledge, such as our knowledge of the star, then they must be equal. Okay, and that's the basic theorem in decision theory. Okay, proven in 1976. Let's make an example. I love working with examples. So, omega 1, omega 2, omega 3, omega 4 are 4 states of the world with these probabilities. I mean, that could be everything, like, the barber shop is open, the barber shop is closed, it's open but it's full, it's closed but it's but there's a queue. I really don't know. That could be everything, anything. So Alice can know if it's open or closed, for example. But Bobby can know a bit more. It knows if it's open, and if it's closed, it knows something more. Okay? For example, that's an example of partial information, different partitions of the state space, right, of the states of the world. And then say that there's an event of interest, like, oh, what's the probability that it's open or that it's closed and is never open again? I don't know. Okay, so we have an event of interest. Now, suppose the true state of the world is omega 2. Now, Alice can calculate the probability of E given omega 1, omega 2, which is this one, which is 1/3. It's 2/3, because it's 1/3 times the probability of this part, right? So it's like it calculates the posterior probability, and it's 2/3. And Bobby also has the same estimate, because she will almost also be here, right? So they agree, and it is common knowledge. They know that if one gets the first partition, then also the other one will. So they don't even need to talk. It's common knowledge. So it's common knowledge, their estimates are equal. Fantastic. Now, suppose the true state of the world was this. As we said before, now Bobby knows a bit more than Alice. So fantastic. We have that they have 2 different estimates. For Bobby, she knows that it's omega 3, and omega 3 is in the event, so the event is true for sure. She's certain about the event. While Alice still has some doubts, right? It could be that the true state of the world is omega 3, it could be that it's omega 4, and okay, so they disagree. But Alice does not know Bobby's estimate. It's not in her knowledge, right? So all these things you can formalize them by doing sets. And okay, could also be that, for example, this is another kind of example. We have omega 1, a state of the world. The partitions are a bit different. In this example, if you work it out, I don't want to waste time now because I want to conclude. Alice and Bobby reach the same estimate in 2 different ways. Alice does it with the vertical set, Bobby does it with the horizontal set, but turns out they are the same and they are even common knowledge. If you work it out, they're both very certain that the other person estimates is 2/3. So this can this can happen in less trivial situations, and it is the basics of like the so-called no betting theorem, that the only way people have to bet against each other in markets or in things is if they don't share a common prior. Okay, so people cannot agree to disagree. If they do, it's because they start from a different culture, or they start from different things. And it is used even in the theory of like negotiations and stuff. Like, okay, you need to get people on a common ground, they will agree. So your job is not to convince them to agree, it's to get them to know the same thing. Okay. Now the question that all of you have been asking, no? So, I mean, of course I've seen it, I've seen popping it. What about observers of quantum system? Or better, let's reformulate the question in your mind. Yeah, why did you talk about quantum computers before, right? Yeah, because people, as we have said, will and already can use imperfect but still quantum computers. Like limited in distance but still quantum communication devices. They will use it, and there are papers on this. Quantum computer for trading, quantum correlated betting things, whatever. People try and play with it. It's a new toy. People play with it. But can they agree to disagree? Let's see what the problem is. So let's go to the basics again. A bit is any quantity that can be 0 or 1. Can be in a CD, in a cable, in a tape. The tapes. Good times. A qubit instead is anything that could be 0 or 1, but in the quantum world. Okay? So for example, an electron can be in the first orbital and the second orbital, and you know from high school that, you for example know from the same teacher as mine, that like we went to the same high school, but she's distracted. So ci ho fatto proprio. But no, they know that it doesn't work that easily. The electron can be in two places at the same time. There's all this thing about superposition, especially there's this uncertainty principle. Holy crap, uncertainty, right? Like no, that's we were talking about certainty before. Okay, there's something bad here. What happens with quantum states is that suppose that 0 is the first orbital, the 1 is the second orbital. Then this electron can be in any of these so-called superposition, right? It can be all over the circle. And what quantum physics tells us is that, if you measure it, if you look at it, you will find it in 0 or 1 with a probability which is proportional to the cosine or sine here, right? So the angle between your basis here and the actual vector that describes that thing. Okay, so what happens is that if you find it in 0, it becomes 0. So you go and look at it, you find it with this probability, and then it jumps to the orbital. Yeah, you remember. Or it goes to 1. Okay, so it can do these things, right? But the problem is that this is the magic. As an electron is the electron, it does not depend on your definition of 0, 1. You could be observing different things. Is this electron spinning this way? Is it doing a wave, or is it doing the other wave? Right? So somehow you can measure different quantities, and these are represented as different bases. The electron is the electron, whatever basis you choose to observe it. So for example, I can choose this one, AB, okay, which is not 0, 1 as I was doing, it's another one. The electron is the same, but now if I look at it, it will become one of the two. And this other thing is also true. I can choose to observe another quantity, and if I measure it, the electron will go here, or it will go here, right? It will not become 0, 1, it will not stay in the orbital, it will still be in between the orbitals, but it will behave nicely according to what I want to see. That troubled physicists, and now must trouble us, because we have uplifted the technology, the quantum behavior, to the non-quantum world. We are users of quantum behaviors. And, it could be that this is like that, right? Or depending on how you measure. So how can you talk about a state of the world? A true state of the world, if the state of the world depends on what you want to see. Other thing that happens, entanglement. So entanglement is even more troublesome, because suppose this is an intuition, right? This picture is wrong. But suppose that you have two things that have been prepared together, and they are prepared so that they are perfectly correlated. Now, as we said before, somebody can measure the first one and say it's 0. Well, because these were pre-programmed to be perfectly correlated, the other one will be 0 too. However, the other person there hasn't even looked at it yet. So whatever they do, it now will be according to what the other person did. Okay, so this is entanglement. This is what I said before, that some systems need to be described as a whole to see the whole picture. They are not talking. This person A and B are acting on the same distributed system. Okay, so the systems are not talking. They are pre-programmed somehow. In a way we don't understand. In a way we still don't understand. But anyway, they behave in this weird way. So, wait a second. Does that mean that what one observes depends on what another observer has done miles away, maybe? And does that mean that there are no states of the world? This true state of the world where was so comfortable for economists, so comfortable for Aumann, so Nobel Prize winning, maybe it's not true in general if we use a quantum computer. Aumann's theorem is doomed. It doesn't work. The stock markets are gonna fall. There will be bank runs. There will be riots, right? So we are doomed. I tell you. Yeah, actually I've done this with Dolly, and I kept the spelling mistake. It was fantastic. And look at this. Look at where is the guy's leg? It's here. Isn't that fantastic? But I kept it because look at the crazy face of this guy. Also, I said to Dali, please depict a bank run in a humorous way. And that's what he done. There's no bank, there's a banknote. There's actually a guy coming out of the banknote. Isn't it fantastic? Anyway, we want our theorem back. And we are doomed without Aumann's theorem because it means that we cannot rely on stock markets anymore. We cannot rely on things being nicely behaved. There could be people who are using quantum computers and they agree to disagree. And then they're gonna bet against each other. They're gonna invest and not invest. What are they gonna do? I mean, we need to understand what happens in order to be sleeping well. At least I've been sleeping terribly. It coincided with my daughter being born, but maybe it's not related. Anyway, calm down. I wanted to be agitated a bit, so I actually managed. I do theater improvisation. I know that the improviser is never truly agitated. I knew what was coming later. So calm down, let's think. Okay, let's think. So maybe thinking will help us. Let's try. This was a start, right? Okay. But are we actually watching the same star? Are we watching the same star? Well, I mean, don't ignore that there are different things. But, let's look at this one. Are we actually watching the same star? What happens is this. When you watch at something, you see something perfectly correlated. Look what happens. Alice and Bobby want to watch this cute little kitty. And, what you think is going on is that they are looking at this cute little kitty. No. They are looking at a light bulb reflection on the little kitty. So actually they are seeing two photons that have passed and bounced on the same object and they are highly correlated. Wait a second, that doesn't make things easier for us, does it? Now we need to deal with quantum correlations. No, this is bad. So we said this cannot be. It's impossible that Aumann's theorem was simplifying things so much. This doesn't work, even in the classical world. I mean, there could be quantum correlations. So we need to check if Aumann's theorem works. And we need to check it because, this was, my friend Adam Brandenburger, economist at NYU, came to me and said, hey, look, I have a new project for us after our failed one. Shall we actually check if Aumann's theorem is true? Because it could be what actually makes quantum mechanics interesting. Despite all the uncertainty, entanglement, blah, 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 Aumann's theorem keeps being true. So, okay, I think it's false, but let's see. I was naive at the time, I still slept. So what would you do? So what we did to make Aumann's theorem non-classical is, okay, we can't think of this nice set of points. There's no such thing. But what we can do is probability distribution directly. So we can just concentrate on what people observe, what people will write down. So what is the probability that this happens, what is the probability that this happens? So we can ignore the bottom part, right? And just talk about events, probabilities, and stuff. So we started doing bipartite probability distribution conditioned on the choice of reference frames, right? So I want to look at this reference frame, Bobby wants to look in this other one, and what's the probability that we observe two events? And so this could be classical if we look in the same reference frame, but not necessarily. So by ignoring what's on the bottom, we actually generalized it. And so we said, yeah, but we can't look at everything. We need to have something quantum there. So we looked at non-signaling. Non-signaling distribution just means that what Alice observes doesn't depend of Bobby's choice of reference frame. Okay, so actually there's a typo here. There should be y prime, but you won't notice. So basically that's something respected by quantum. So if I choose a reference frame and the other person chooses another one, my statistics are the same. I cannot tell what reference frame some person has chosen. Otherwise, there would be faster than light communication, like grandfather paradox. I could go back in time, and not cool. Everybody will be waiting for Back to the Future Part 4, but I am not comfortable with this in reality. So this is respected by quantum, and so we abstracted everything. We used something which is called non-signaling box. That is, physicists love these things. Like, oh, let's just put, and computer scientists, let's just put everything in a black box and see what happens. So what we did was, okay, can this give disagreement now? And we start saying, okay, so boxes classically could be like this. See, like here there is Alice's choice of, I'm looking at the, with the reference frame that will give me my partition, or I'm looking with the reference frame which will give me my event. And Bobby does the same, partition or event. And then, you know, they have, these sets have some intersections, and you put the value there. Right, I didn't even bother filling the whole thing. It's like, you know, you see what is gone, right? So 1/6 here is like the intersection of the two blue and red things at 0, 0. So here, 1/6, right? And so on. So there's a mapping from what Aman was doing and the abstraction we are taking. Just think of the box. And of course, like, this is simple, but it could be that, you know, the intersection is more than one thing, so you sum the probability. It's non-trivial. But okay, let's do that. And let's think of an operational interpretation, right? So Alice and Bobby have a box. They both choose to look at their partition. So they are here. For example, we assume that they observe 0, 0. Like, we assume that there's a true set of the world. We assume that happened. And, you know, but they're interested in what would have happened in the other case, the event of interest. So each of interest to, you know, what would have happened if they had actually observed the other event, right, to estimate that probability. So yeah, so that's in the box is located here in this kind of hybrid thing, like, oh, one person accessed that. It's all trivial classically, but in quantum really matters what the other person did. That's why we are not here. Classically it would be the same, but in quantum we need to be there. Like normally everything works out, but yeah, we generalized it. Right, so they announced their estimates, QA, QB, and then they just calculate to see if they are certain, not no, because I don't use the knowledge, because knowledge doesn't have much sense in quantum regime, so we use certainty, it's a technicality. But okay, so what they do, they go on the board and they ask, okay, what I think that the output of Bobby was, what the output of Alice was. And they do these calculations. Don't look at the calculations. Just notice that they're not talking about states of the world, but they're talking about input-output sets, like A, B, given X, Y, stuff like that. Right? They're talking about larger events. So we reproduced this whole thing, and we got that, okay, there is common certainty of disagreement, like agreeing to disagree, if this thing happens, right? There's a property. But the property only relies on, like, an event, not a specific state. Okay, so fantastic. And okay, this reduces to Haumann's theorem. So classically, this is impossible, and you know, everybody's happy, everybody must agree. But can it arise in the more general setting? And what we found is, yes. Unfortunately, this is an infinite class of boxes that will give rise to disagreement. So we just started with, like, you know, filling the things, and we used only the constraints we knew. We imposed that QA was different from QB, and that in the end they would get the disagreement, and we obtained this box. I remember filling 3 blackboards in a row trying to find this, and we found it. Like, you know, me and my co-authors, clearly. And we were saying, like, no, this could be difficult, but no, we also found an example, and notice how some probabilities are negative, because that's what happens in quantum. And it's like, oh no, if you have this little thing, then the world collapses. There would be like market crisis. There would be bank runs. There would be riots. We are damned forever. Like, let's keep this thing secret. What are we gonna do? Calm down. That was more general than quantum. We only assumed a box that was non-signaling. Chill out. We went back to our quantum mechanics book. We did the calculations and said, okay, let's write this box, but in quantum mechanical terms. There was a theorem by Thilerson, page 25, that said, oh, look, if a box is quantum, then you can simplify it this way, in this linear algebraic way. And we went and said like, okay, let's do that. And we found that like in quantum, if you implement this with RSTU written there, you violate this equality which was necessary for this agreement. So this is exactly QA different from QB more or less. And we have a proof, actually a like 10-line proof, as simple as Aumann's proof. Aumann started his paper with like, oh people, this is very embarrassing, this is like so simple mathematically, but I still want to publish it because it might be important. Nobel Prize. I'm not saying I'm gonna get Nobel Prize, but our thing is as simple as this, and we think it's as important. Okay, and this is also fully general. We generalize it, so we do it for 2 by 2, but we prove that any situation that quantum can create will not violate the thing. Okay, and so Schrödinger's cats love each other. They always agree. And it's good. No riots, no bank runs yet, and especially no protests with a typo in the theorem thing. So now we come down. We are very happy. We have done something nice. We have doubted the basic things that are so given as a given. I mean, they're taught as a given by people who use these things. I've seen several works that assume that this will happen, but we have given them a proof. Okay, so and now the quantum internet, which will soon be a reality, definitely sooner than full-fledged quantum computation. So we have it, we will have it, we will want to use it to take decisions, communicate securely, optimize, save energy, and this will probably make sense. I say probably because there's still work to do. We really want to get back to the basic of the epistemics and keep proving these things that are necessary and keep seeing what the implications are. Very often we find important differences, but this is the thing. So we published this in Nature Communications, and we went to the 2021 top 25 physics article. We really would have liked to be top 25 economy articles, right? We also are one of the most read papers, but one of the few citations. People that don't know what to do with our thing, right? They don't know what to do with our thing until 2 weeks ago, a month ago, Zip Hellman and Miklos Pinter, they are relatively famous economists. I don't know if you know them, but they cite us in their paper, and they say basically, we distinguish 3 types of no-trade theorem, and one is agreed-to-the reversion, which is Aumann, or Contreras-Tejada. Contreras-Tejada was my collaborator. They actually start saying that the notions that we use here are inspired by ours. So maybe things are going to the right direction, and the economy community is noticing this. But I really maintain that, I do these things because I have fun. This actually was my pet project, was not even in my postdoc. And normally I do worse things in my official things. But thank you for the attention. I really hope this opens a bit your spectrum of thought. Thank you. We have 10 minutes for questions if you have any.
Just one question for clarification.
So wait a second. They told me that I need to give you this.
I can also speak up.
No, because
For record.
to record the talk because the
Maybe it's
microphones are directional.
but maybe it's a stupid question.
Probably it's a stupid question.
Thank you. That's encouraging. So.
There are no stupid questions. There are stupid listeners.
Okay, that I get. No, well, the question is about the comparability between game theory and quantum computing, because in game theory you know the framework, right? You know the outcome, you know the decisions and everything. And now you have some tricky things like a superposition, for example. You don't know what it is. So how can you compare quantum theory with game theory if you don't know what the decision will be? I think you touched upon it. So that was just for me a question of clarification. And one content question, what's a Byzantine agreement? That's just very...
Sorry?
What's a Byzantine agreement? It's on the top list.
Oh, it's a protocol in, okay, I answer the second question first.
Thank you.
A Byzantine agreement is a protocol in security, which is basically related to this secure multi-party computation, where you have a function, everybody wants to, for example, compute the output of the function, which could be who is the richest among us, but people want to keep the inputs secret. So you have F, X, Y, Z, where X, Y, and Z are the wealth of, I don't know, Elon Musk and Bill Gates and somebody else, and you know, you want to know the output be public, but the inputs be that. And I think Byzantine agreement is a variation of these kind of protocols. And how do you do that? How do you use game theory? Well, what we are doing is abstracting as much as we can by only thinking of the observable part of quantum mechanics. Quantum mechanics has observables, and we work with those. And there's something underlying, which is like the ontological model. We try to not depend on any in particular. But also, we do a study in game theory using quantum computers as a resource, which are only like quantitative in a sense, like, what kind of equilibria can you reach by optimizing over this kind of calculations, not these others, right? So like this is the example I was doing with Yoda. Yoda would be the advisor. Imagine that instead of Yoda, we put a quantum computer. What kind of advice can we reach, and what kind of equilibria can we do? We actually have a paper published the same year, 2021, in Theoretical Computer Science, where we give a framework on how to work in games of incomplete information with quantum advice. Right, so this is our approach, and I've seen many approaches that are not that clear. But,
Thank you.
You're welcome.
Well, I have a question.
No.
Into the
He trusted me so much.
the question is, how can you make it so funny?
See?
No. It's a serious question. The question is because communication now is an important paradigm into the economy of knowledge. What do you think is going to be the future if this quantum communication happens in reality in the future? What could change, like the big impact that we could face in the future?
Well, I think there are some important factors there. One is that there are some distributed problems for which the amount of communication is dramatically different between quantum and classical. But then we will get into communication complexity of sorts. Like this is more like something that computer scientists like playing with. I think it would be mostly a mindset of like the way you do communication is like, you do classical chitty-chatting, cheap talks, whatever you want, but you try to minimize it by encoding things in a qubit and sending those. So I think more people will have to study how quantum information works. You can save some sort of thing, but consider that quantum channels will be more expensive. So I guess the first obvious application would be for security, where there is an increase in security that quantum channels provide, but also for like important important correlations you need to get between some big entities that can afford this. But how will they change it in general? No idea. This is something that I would like to see. Don't know if I answered your question or just dodged it, but yeah, there's not much I can say. It's like there are tons of examples in theory of things that you can do. I haven't seen any in practice yet, apart from crypto.
Can I ask another thing?
Yes,
Thank
please.
You say that the quantum computer doesn't need energy to keep going, to keep working, but it needs a lot of energy to keep cold at the beginning. So how do you think that the cloud computing could be a affordable solution to offer this service to the population at all?
I'm glad you asked this question because it's something still very unclear. I mean, I've seen no. Well, there are some studies on comparing computing. Teraflops of computing per kilowatt, whatever. I don't know. Yeah, we still don't know what the final technology will be. What I can say is that in theory, if a quantum computer is implemented perfectly, it consumes zero energy. And so the energy consumption would be more or less a constant of like keep this thing cold. So you have a big constant at start, but it doesn't scale badly with the computation, while a classical supercomputer will scale badly with the computation. The more you send to do, the more it will like heat up, right? And you need to cool it down. While a quantum computer will be like, okay, if you load it at max, it still computes the same as if you don't use it, right? So there's a big like initial constant cost, and so the applications would be will have to be studied. But for this, it's more a technology, like engineering point of view than another. But definitely, you can think of quantum computers as a cloud computing service, and that's what, for example, Amazon Web Services is trying to do, and IBM is trying to do. You connect on their website, you write your program, and you say send it. It answers like you, and it does. It really looks like AI in this sense. But so it needs to just be in a specific place. I don't think it's very feasible, at least with the current technology, to have small quantum computers in universities and stuff. It need to be big data centers. Like Barcelona Supercomputing Center is building one. It will be the first public quantum computer. So that's quite big. But yeah. So this is the situation. You can think of it as a thing, and you can think of it as a GPU of sorts, right? So these are computers that will probably do specific problems, and you say like, oh, do I need to solve this search in an ordered set? This can do it faster. So call the quantum computer like GPUs. Do I need to do something graphics? That's fantastic. Call the GPU, right? So think of it this way. Yeah.
Thank you very much.
You're welcome
for coming.
You were a great audience, I have to say. Thank you so much. Okay. Back.
Are you using your own laptop?
Yeah, just using my own.
It's okay. It's okay for you.
Yeah. Stable.
No, it's the problem is because you are going to project everything on the screen.
So good.
So this is the name. So it helps a lot. Well, this is what I told you.
I think I have it somewhere.
So here is Espen Pedersen, but it's also called Espen Ragbe.
Esben Rabi Hjertum Petersen.
Thank you. He's full professor at the Copenhagen Business School. It's a very prestigious business school. They have a long tradition in researching on sustainability and corporate social responsibility. So we are very lucky because he is visiting us here. So it's a great pleasure to have you here. Thank you very much for coming. The floor is yours. Thank you.
Okay, thank you. Yes, Glad to be here. Heine kindly asked me to say something about our work, or my work in stakeholder management, stakeholder theory and sustainability, and that's what I plan to do. So it'll be a little different probably from quantum computing, but I hope you'll get a sense of it. Yes, and as Jaime kindly mentioned, we have done a lot of research on sustainability and also different types of stakeholder theory approaches over the years. Actually, my PhD way back in 2006 was very much about stakeholder theory as kind of the core foundation of my PhD. But since then, we have used it in a number of different ways for a number of different projects, whether it concerns sustainable business model, labels, measurements, partnerships, yeah, all of the things Jaime kindly mentioned. And we have also built it into some of the work we have done. I would like to kind of brag of some of the online courses we have developed on sustainability and business model, whether it's business model for sustainability, sustainable fashion, but also for public schools on how to kind of work with sustainable fashion. So we have kind of applied it in a number of different ways. How many of you are familiar with stakeholder theory? So, quite a few actually. Very shortly, stakeholder is about the group and individuals who affect or can be affected by the operations of the company. And there's a lot of discussion about where it started or when it started. Some related back to the 60s, some related back even before. But I think today most people affiliate very much with 1984 book by Edward Freeman, who wrote this stakeholder theory and management, strategic management approach. And it has become he has become the godfather of stakeholder theory, still published in this area. So I think the 1984 book is definitely maybe the right place to start. He actually always have an anecdote about how he tried to publish something about stakeholder theory in the 1970s, but then he got his manuscript returned from the publisher, who said that he has misspelled stockholder. Nobody knew what stakeholder was like in the 1970s. But again, some kind of related to a kind of previous go back. And some even claim that it has some Nordic roots, which I'm of course happy with. We had a former PhD student, Robert Strange, who's now at Berkeley, who was always, trying to promote this idea of Nordic sustainability, Scandinavian approach to sustainability. And he claims that some of the roots of stakeholder theory was actually from some Nordic scholars who went to the US. I'm not sure about it, just like I'm not sure about whether there's a Scandinavian approach to sustainability, but I mean, of course we are flattered when we hear things like that. Yes, you can say that there's a lot of things to say about stakeholder theory, but one of the things you can say is there's an underlying idea of harmony, that over time stakeholder interests will go together. That's the idea, otherwise why should they kind of team up in a company? It might be that there's short-term conflicts, it might be that there's a diverging interest and so on, but over time suppliers want to be with a company because it makes benefit or gives them benefits. The customers want to be with them because they provide a product and so on. So there's this underlying idea of harmony in the long run, and that has also been one of the kind of critiques of stakeholder theory, which also implies that, strangely enough, stakeholder theory is both accused of being a communist idea and being accused of being a kind of a capitalist plot. It's accused of being a communist idea because it kind of say that it's not only about shareholders. We should also take care about other stakeholders. So maybe it kind of, there's been this I would say, pseudo fight between, Milton Friedman and Edward Freeman, even though they basically agree on everything. But they have tried to portray kind of Freeman as this big kind of communist, which is basically a crazy idea. But anyway, that's one stream of literature, and then there's another stream of literature who says that, stakeholder theory is kind of a capitalist plot. It's just to make capitalism sound nicer and more inclusive, but fundamentally it kind of runs against the interest of the people or the oppressed or whatever. So there's actually, it's a kind of fun theory in the sense that it accuses from both sides of the political spectrum. Then I just wanted to say that there's this underlying idea of separation thesis or criticism of separation thesis, which is one of the things I like about stakeholder theory, that actually a lot of CSR and corporate sustainability literature kind of leans itself towards stakeholder theory, but stakeholder theory is not that happy about, especially not corporate social responsibility. Because essentially they criticize this concept for trying to make a split between the social responsibility and the other responsibilities. And what kind of stakeholder theory is fundamentally against is this idea that you can kind of make the world into these chunks and say that you can separate the economic from the political, from the social, and so on. And that's perhaps where Freeman disagreed the most with Milton Friedman, because that was a criticism of Milton Friedman, that he tried to say, okay, economy, that's business, and politics, that's government, and that's not how you actually can think of the world. And I think this is a very important point. Then again, also part of the problem is actually the graphical representation here, that is depicted like this, and it has never been the intention that this was the actual portrayal of the stakeholder environment. But critics have used it again and again to criticize stakeholder theory, because why should there be an equal distance to the company? Why should all the bubbles here be the same size? Why is the company in the middle? What about the connections between the kind of the different stakeholders and so on? So there's actually been an ongoing discussion about how the right stakeholder model should look like. But that was a very, very, very brief discussion of kind of I would say the foundation of stakeholder theory. The company has stakeholder. The company has responsibilities towards stakeholders, and actually managing for stakeholders is a better way to run a business than any known alternative. That's basically the core premise of stakeholder theory. Then, from this kind of general kind of thinking about stakeholder theory, there's a lot of kind of key questions. One of them is, of course, who matters? And this is not only a conceptual discussion, there's tons of different ways that you can kind of group different stakeholders, primary, secondary. There's a famous article by Mitchell and some of his colleagues where he talk about power, urgency, and legitimacy. There's, dozens of different models. But it's actually also one of the areas which are kind of flown into kind of the practice worlds, perhaps most notably the materiality matrices and indexes that you see in practically all I would say sustainability reports. So this idea of figuring out who actually matters is actually a key obstacle, because also was mentioned here that stakeholders determine what issues we talk about, but issues also determine which stakeholders are important. So there's not kind of one kind of group of stakeholders that always matters. It's very much issue dependent. Big problem for management, and that's the little question that a lot of these assessments are done by management themselves. And I had kind of this Nestlé materiality index that they have in their sustainability reports, and it looks very nice. You have impact on Nestlé and stakeholder interest, but again, who made that grouping? Who was involved in this grouping of issues? How many did they ask? Was it only friends and family? Was it actually maybe, I would say, a very selective group that got invited to have a say on this? I have been invited also to take part of materiality assessment, and it was basically because I knew the sustainability manager in that company. And of course, that's not kind of the right way to do it. I think one of the key, messages of stakeholder theory is that you should also talk to the critical stakeholders, those who are not, friends and family, and from this extended group that you work with. Of course, there are limitations. If you are, I don't know what, selling beer, then it doesn't make sense maybe to talk to people who don't want anybody to drink, for instance. Maybe there could be, but I mean, there is sometimes limitation, but you should also talk to the critical stakeholders. Just as an example to illustrate the problem, I found this one, and you can probably not see it, but here you see responsible marketing and influence, and this is Nestlé. It's something that has major impact and something that stakeholders care about, according to Nestlé. But what happened if you change the company? Here I found Unilever's materiality, and suddenly responsible marketing and advertising is suddenly down here. So what was here? You have business impact and stakeholder importance. So again, who did they actually invite to take part in this stakeholder mapping? Who was actually kind of the one who kind of influenced them into kind of placing these different items in different places? I actually think it's actually worth some research to find similar companies and see if their the materiality index actually look the same, because I'm not always convinced that is the case. And there's also several other differences. So it's not like exactly objective science. I know there's a lot of researchers here and PhD students. I would say I have done a lot of mistakes when doing stakeholder research, because I think the traditional way of doing it is essentially to kind of make a list of stakeholders, employees, suppliers, customers, and so on, and then go out and ask people who matters the most on a, let's say, 1 to 5 scale, where you list them all. But what we found out doing interviews were that if you actually present people with, let's say, a list, then everybody matters. I mean, because you kind of have this aided awareness that you actually, of course, NGO matters, of course, the distributors matters, of course, the owners matters, and so on. But if you don't show them a list, they always talk about the customers, the employees, and that's about it. So there's a big difference between, actually giving people a kind of palette of options and actually just asking them openly who matters. And I think I have an example here, where we basically ran a survey where instead of having this list, we kind of just asked them to say, okay, mention a name and then group them into different categories, and then see who actually came out as important. And as you see here, there's actually suppliers and customers, in this case also consumers in the fashion industry that matters. Everybody else is kind of peripheral to the managers here. Interestingly enough, and that's actually something we have found also later on, is that owners, we talk a lot about the shareholders and profit seeking. Managers hardly ever mention shareholders or owners when we talk to them, because kind of their interest is kind of served if they do this well. So again, I say, and we have kind of studied that in a number of cases, it is very much upstream and downstream, and that's it. And then employees also matters, and everybody else is maybe kind of second to that. So I think there's some barriers in the way you have done it. I think I should. I'll get back to that the conceptual. So I think it can definitely be kind of developed, the whole field of stakeholder theory, in terms of measuring it in a more clever way. and maybe also make use of technology. And I have a small example here. I had a bright student who was studying data science, and she started rambling about, web scraping and stuff like that. So we got our hands on all Twitter data before they started charging money for it. And then we actually started to kind of building a kind of network model and see, okay, when we talk about greenwashing, what kind of companies come up, which stakeholders, who's talking about what. And we're actually trying to repeat the exercise now with sustainable fashion, which is a little more complicated. But as you can see here from our analysis, firstly, it's always the same company that shows up. It's always, the Shell, it's always the Exxon, it's always the same company. It's always the same kind of activist stakeholders who kind of pop up. There's even, at least in social media, there's a Greta Thunberg effect that she's always there talking about greenwashing. But also, what I actually didn't know, or I should have thought about it, was that actually Guardian is kind of the hub for talking about greenwashing. And the message is essentially that actually by using some of these, I would say, natural occurring data that you find on social media and so on, you can actually make some clever, I think, stakeholder models that actually shows who's actually involved in different types of discussion. You can also make sentiments to this analysis. Are they negative? Are they positive? And so on. You can do a lot of interesting things. I didn't know you could, but I had a bright student, so that helps. So there was this kind of clump where you have the Guardian and energy companies, and then you have some of these petition websites that was targeting mainly consumer companies. So I think this is another way of kind of doing stakeholder analysis, and I think there's plenty more to do there. Another key question, and that's actually not only related to stakeholder pressure, that's this idea that there is some demands from the outside and then there's some response from the organization. And that's something you see in all literature. If you have read the literature on paradox or tensions, there's an endless number of typologies of different types of pressures and different types of responses. And as mentioned here, they always go from either a little to a lot, or from something that is coupled to something that is decoupled. Actually, almost without exception. But I think one of the mistakes I have made was maybe to kind of assume that, the company has one type of response, because I don't think that is the case. And I think that this idea of aggregating kind of firstly pressures, but also responses are born with some limitation. And I hope in the future there will be some more advanced model which look at, let's say, combinations of different stakeholder demands and combination of different stakeholder responses, because I think that's more accurate. However, taking this stakeholder analysis, we did this. And even though, of course, stakeholders are different, companies react more or less in the same way to all pressures from stakeholders. Large majority, they just comply. It's easier. If they are met with a demand, they try to comply with it. Nobody kind of wants to resist very harshly, and nobody wants to be too proactive, because why should we be the first one to experiment with new stuff? It's very much compliance that dominates the picture, which is also a little bit interesting when you make these type of elaborate models, and they can be very long, these models, that in fact, conformance is by far the most important one in most of the cases. Again, companies are successful because they comply with the demands that they meet, not because they are on the forefront. So again, this whole idea of a kind of responses to pressures is also a big part of what stakeholder theory is about. Another big chunk is about stakeholder engagement, which is something that has kind of occupied the minds of researchers for quite a long time. Again, there's also some debate about how inclusive have they actually been? Who have they invited? Again, is it again friends of families? Are they taking in the perspectives of, let's say, the oppressed or the marginalized, or let's say the non-human environment? And there's been, a lot of critique in the way that companies have done stakeholder management in practice. I think maybe if I should critique the critique, then I think some people kind of underestimate the cost of stakeholder engagement. I mean, you cannot have comprehensive engagement with everyone because it has transaction costs associated with that. So you have a kind of very deep engagement with a few, and then you have kind of more transactional engagement with the many, so to speak. But this is been a recurrent issue in the stakeholder engagement literature. I don't know if you're familiar with this Ben Spar case, where I think it's a classic example of how Shell had this oil storage they wanted to kind of dispose and dump it in the North Sea, and they actually had a very big stakeholder engagement process. But what they didn't do was to kind of engage everyone within a kind of the same group. In this case, they had conversation, I think, with Greenpeace in the UK, but they forgot to kind of invite Greenpeace from Germany, which have a different perspective from the Greenpeace in the UK. And they also forgot to kind of expect how would they react when this actually popped up as a crisis. Who would try to manipulate the data and so on. So it's an ongoing issue how to do this in practice. In terms of maybe for you PhD students, I think a lot of this research has been quite, I would say, simplified, including the stuff I have done, because in fact, if you actually take a deep dive into some of the bigger companies, they have very comprehensive stakeholder engagement tools, but they hardly ever find their way to kind of research journals. They are very complex, they're very detailed, they have very long list of stakeholders, individual stakeholders. They have very standardized approaches on how to kind of talk to different types of stakeholders. They can make different presentations to different types of stakeholders. I mean, they have a whole kind of organizational routines kind of built into kind of target different type of stakeholders in different ways, and a whole kind of manual for doing that. And you hardly ever see that in journals in any level of detail. We just took a very superficial view of this in an article where we kind of looked at how a company kind of work with stakeholders that they only have occasional relationship with. And again, this is only a very simple example, but they actually try to make all types of kind of grouping and all different types of engagement strategy depending on where they were, the value, the present relationship, the governance type, and a lot of other things. And I think this is quite simple model, and if you go to, let's say, the Shell or the Novo Nordisk or so on, they have much more comprehensive models, especially, and this is only the ad hoc stakeholders, especially for the permanent stakeholders. So this can become much more complex. Related to engagement is stakeholder collaboration. There's a lot of literature on cross-sector partnership and collaboration, and it very often kind of builds on stakeholder theory, although I would say that it has not really matured to the extent that I personally would have hoped, because I think it started very much with Timothy Rowley, who wrote this early piece on stakeholder network theory, but it never really kind of grown so significantly, at least that would be my claim, and it has not really kind of been built in enough in corporate sustainability research. As mentioned here, you have a circular economy you cannot have a circular economy solution without having some type of assumption about collaboration between stakeholders. So I think, I can hope at least that stakeholder theory will be much more applied in circular economy and circular business model in the future, because right now I think it's maybe an under-researched area. We made a special issue about it, and it has at least some attempts to kind of try to merge sustainability, business model, and cross-sector collaboration, because again, a lot of sustainability can no longer be solved by the individual company. It needs to kind of be solved in these multi-stakeholder collaboration. Again, circular economy is a good example, because in order for any circular solution to work, there has to be enough value for the next stakeholder to take care of a product and service. Otherwise, it's in the landfill and so on. And why should you optimize your processes to create value for somebody maybe 2, 3, 4, 5 steps down the chain? That is a kind of fundamental problem. And unless you solve that, I think a lot of circular kind of solutions will be suboptimal, to say at least. Stakeholder prioritization, I mentioned that you have to prioritize somebody, and it has also led to a lot of different research on, decoupling and other types of research. There's some people talking about also greenwashing yesterday, and again, when you have kind of greenwashing, you are kind of deliberately trying to mislead your stakeholders, whether it's the customers or other types of stakeholders. And it can be, in fact, not only kind of greenwashing, but also all these, in between and elements from bullshit, which had a small research community, hypocrisy, decoupling, aspirational talk, synthetic silence, greenwashing, and brownwashing. All of that is about kind of building some type of discrepancy between saying and doing between you and your stakeholders. Which will just, since it's about sustainable business model, mention the recent piece, very simple piece we wrote, where we basically took this old greenwashing claim from Delmas and Urbano. I think it's still one of the most cited papers on greenwashing, which started off by saying that 95% of products surveyed in 2008, 2009 committed to at least one of 7 sins of greenwashing. A lot of other surveys have been done since then. Sometimes it's 40%, sometimes it's 60%. But I think our assumption or our idea was that when we're talking about this type of percentage, then it's not just the few companies in the markets of the industry that do greenwashing. It's actually in itself some type of business model to greenwash. There's something that you do deliberately and that companies do by design that actually mislead stakeholders. And that's why we try to have this classical business model templates and then say, okay, where can it go wrong with a different type of stakeholders when it comes to greenwashing. So I think stakeholder theory also kind of fuels this whole discussion about decoupling and greenwashing and all of these discussions we're having now. So that was basically an overview of some of the stuff we have done. Future perspective, where do I think there will be kind of a future for stakeholder theory? I think there's definitely future. I also think there's also some open doors to make a contribution. I think 100% it will continue to be kind of embedded in the literature on sustainable and circular business model. If you take any definition of sustainable business model or circular business model, there's always this idea about it's about having a whole, more holistic view of value, the true bottom line, but then there's also assumption about stakeholders, creating value for stakeholders, and then there's an idea about long-term. So stakeholders are simply built into the very definition of sustainable business model as it is now, and will continue to be so. And again, as mentioned before, that circularity is very hard to talk about without having some talks about stakeholder. And then there's, of course, the risk when they don't do it. A very recent example, and I just wanted to show it because it's pretty clear. I'll not go into the details because I'm not into structural equation modeling, but luckily my co-authors are. But essentially what this model shows you is that you have stakeholder demands, you have business model innovation, you have corporate sustainability, and here you have resource availability. And we just finished this analysis, and it's one of the times where you just get very happy because there's just a perfect kind of model here. That everything fits together, which basically means that stakeholder demands are kind of related to business model innovation. Business model innovation is related to corporate sustainability, and stakeholder demands are also related to kind of corporate sustainability, and resource availability moderates relationship. It's still under development, so I don't have kind of the exact, but it clearly shows that companies who are innovative, they are the ones who experience the most stakeholder demands. There's not like, if you are operate in a business environment where you don't have a lot of demands from stakeholders, there's no reason to innovate. Likewise, if you are, when it comes to corporate sustainability, if your stakeholders are happy, why bother subscribing to a new certification? Why do another type of sustainability? So again, I think stakeholders and stakeholder demands is just a very important kind of driver of innovation and corporate sustainability. I would say the latter, this relationship is very well documented. I think maybe the linkage here is more novel in the sense. So I think looking at stakeholder theory to explain innovation can only become more important in the future. Then I think if I should be critical to stakeholder theory, I would say that it has not evolved as much as a lot of other theories. I mean, the Ed Freeman book from 1984 was actually published the same year where you had DiMaggio and Powell's famous article about the iron case. I think it was somebody talking about the isomorphic pressure kind of earlier today. And you can see how institutional theory has evolved since 1984. I mean, it's a massive kind of theoretical perspective with a lot of subfields, whether you talk about institutional logic, or institutional work, institutional entrepreneurship, kind of all different types of institutional theory. We have not seen the same with stakeholder theory. And again, I'm not going to motive analysis, but I think part of the reason is that it's probably the same 5-10 people who has kind of written basically everything there is to write about stakeholder theory. So we have not seen this big evolution of different subfield of stakeholder theory that I think could be kind of could be necessary. And I think this is something that could be developed much more if somebody is kind of able to build a new and more comprehensive model of stakeholder theory. Because there has been attempts, to bring in perspectives of agency theory. There's been attempts to bring in paradox theory, negotiated order, decoupling network, but it has never really become integrated in stakeholder theory. So if the first guy or girl who can do that will actually have a very very successful piece, I think, because it has not evolved so much. In my view, at least, you can challenge me on that one. Then I think another field where you could kind of hope for development is again looking a little at the errors, as I think I wrote here, that instead of only looking at the who, the stakeholders, and the relationship, who matters, and so on. I mean, you should think about all the other things that flows between the company and the stakeholder. It's not only relationship, it's not only pressure and response and so on. There's tons of different, I think I showed it here. There's a lot of the kind of contracts and knowledge and learning and data and goods and services, routines. a lot of other things that kind of goes on in here, and I don't think it has kind of been received the attention that it should in order to kind of explain the stakeholder theory. It's still very much the actors that is the focus, and I think one way of kind of developing kind of a stakeholder theory would be to take in all the other elements that are built into stakeholder theory and try to make a more kind of comprehensive theory of stakeholders than one we see now. That would again be my claim. Then finally, I think there's a brand new world of data and different opportunities for doing stakeholder analysis. I would say that we have tried to do it with Twitter, and that's of course one way of doing it, but some, I would say, other sources of data are more protected. But I mean, think about what you can do with Google data, think about what you can do with AI, think about all the companies which are kind of collecting data on stakeholders of various kinds. We are doing some collaboration with a health organization. It's very difficult, by the way, but I mean, there's so many things you can actually do to make more comprehensive stakeholder models. Also talk with all of these companies that do different types of audits of company, building in sustainability into all the quality systems, all the different planning systems, quality systems, and so on. There's tons of opportunities actually for using data to get a better view of who actually matters and how they matter in an organization. However, there's always a problem with this, with new technology. I don't know if there's been a lot of discussion about AI and the strange answers they give and so on. But I think fundamentally, there's a lot of trash data out there. And I think there's a lot of noise if you want to have the real information about what's going on. It's actually very protected. As mentioned, we look at health innovation and digital systems and so on, and getting access to data is just such a hurdle. And people are trying to kind of protect the data, and they are using basically GDPR rules to defend status quo. That's the real motive. Nobody has an interest in sharing data in certain fields, and you cannot really kind of reap the full potential of let's say, using data to make a stronger stakeholder theory unless you can kind of solve this issue. And that's continued to be a hurdle, in my view at least. Again, this was just an article that was published on supply chains, but I mean, you can have it the same with customer data. You can have the same with all other type of data that you can think of. So I think that was my kind of a short speech. Thank you very much for your attention, and if you have any comments or questions or disagreements, then feel free to we can help them now. Thank you. Any questions?
Thank you very much, Professor. I have a question, because in the field of business and human rights, you have a kind of a similar issue with the accessibility of the affected people. In that case, it's the stakeholders. In business and human rights, it's the right holders. Is there any research or any concept towards engaging those stakeholders directly? Because, of course, if corporate management is fantasizing about what the stakeholders need, there's one way to find it out, to ask them. And similarly to human rights, you ask the people how they're affected. So is there any research stream into stakeholder engagement particularly?
Not, I think, beyond actually, when it comes to human rights, there's a debate between human rights scholars and stakeholder scholars, because again, human rights scholars would say it's not about interest, it's not about needs, it's actually about rights. So it's something, somebody has a right no matter if they matter or not. I think that would be their claim. But if you have these, due diligence processes, this what's called Rocky framework and stuff like that, for instance, in human rights and supply chain and so on, you face essentially the problems as normal stakeholder management, because again, you should find that you should make a prioritization of your suppliers, and then they should list the suppliers, and there's so many things that can go wrong at the different stages. So I don't think really, I'm not sure human rights has solved the problem. I think they're actually very much aligned, at least from my superficial knowledge about the Rugby framework and stuff like that. But I know that conceptually they have a disagreement about it. But it's difficult. We had a case with Arla, which is a Danish dairy company, who got brought to, what is it that we call it? We have a human rights committee in Denmark because they violated the rights of the West African farmers and ruined their local markets and so on. But it's so difficult because are they really competitors? Again, what can you do? But then they solved the problem with some type of multi-stakeholder engagement and inviting different people up and so on. They didn't really solve anything, if you ask me. There's a story behind that. But in principle it works. But I mean, you have all the practical transparency, lack of transparency, and so on. It's the same.
Thank you.
Okay.
Thank you, Professor, for the presentation. When you were talking about materiality studies, I mean, I've been part of some, and something that I used to think about it back then, but today I got reminded of it, is, I think corporates find it very difficult to bring communities into this kind of conversations. And I felt even back then that the issue was not so much that at least the representatives could not be brought into such discussions, but it was language. And because some of these, and here I bring in the whole role of what consultants do for corporates, a lot of these materiality assessments are done by consultants, for example, or consultancy agencies. And I felt back then that language and the fact that a lot of these communities, logistically, like just by the fact that they don't speak the language, can't be brought into the discussion. And I still think what could be the way to do it, where we don't leave out the critical voices, like you said, who are the critical stakeholders, and especially for mining industry or, industry which is industries that are very close to, which have to work with communities or which somehow result in displacement, whose operations. I feel that there's some disconnect that is not being bridged, even after many years of materiality studies maturing.
Yeah, I think that's right, and it's it is a problem, but it's also, community is also maybe a loose concept sometimes, and also I'm a little reluctant to romanticize the community, because sometimes the community is also very selfish, so to speak. We have a discussion with wind power in Denmark, and there's been a big opposition against wind power until the wind power companies found out that they could just give a share of the money to the local community, and then all criticism stops. I mean, it still might ruin the landscape, it might have negative influence on God knows what and so on, but just give them a little bit of money and everybody shuts up, and it seemed to work. I mean, but so the community is not always the good, but I think there should be smarter ways, it should be possible to develop smarter ways of community engagement. I don't know if you know, there's this scholar, what's it called, Bobby Barney or something. He's a super critical management scholar. He always had this example with the mining companies in Australia, where they did all of this community studies and so on, and there was a guy doing it, and then they came back to the companies and say, yeah, it's wonderful, we are all in agreement, all the communities, they are just in agreement about, mining companies. Yeah, oh yeah, that's great. They think also you should fuck off. that was it. And then he got fired, and then they didn't do so much come and see engagement afterwards. So again, there is kind of, it's tricky. You want, critical voices, but you don't want too critical voices. I mean, there's certain agendas that cannot be discussed. And it's the same with the political discourse, that in politics, I don't know if it's the same here in Spain, but in Denmark you have certain community groups who have a right to be heard, but they do not have a right to make a decision. And again, people can make noise, but I mean, in the end, they do not really have a say on this. Somebody else kind of agree. So there's a lot of kind of interesting tensions and paradoxes, and it also maybe go back to the idea: can we actually assume harmony in stakeholder theory, or are there some fundamental tensions that you cannot solve with this theory, where we need something else? Yeah.
Well, I thank you very much. I have one question. Because all the PhD students that are attending this presentation belong to different schools, and they are like researching in different dimensions. Yeah. So I would like to ask you if there is any kind of perspective to consider, like how to manage stakeholders into engineering in different disciplines of engineering, like if there is any kind of criteria to work with the topic or classify them or something like this, so they can include this perspective also into their research.
I probably need to elaborate a little on that. In engineering, what kind of, some special kind of model for that, or what do you?
Yeah, if there is any kind of perspective that they could help them to include the concept of stakeholders into the research.
Depends, I think, also what type of engineer you are, probably. But I mean, I think a lot of the models are quite generic, also the processes. I mean, there's huge reports being made about how to do stakeholder engagement across different kind of disciplines and so on. So I think I can only think of the kind of the generic kind of the model, not something particular to this, I would say.
Oh, thank you. That was very inspiring. Thank you. I'm also working on project management discipline, and we come across a lot to stakeholder management in the previous decade, especially in the project management institutes, knowledge frameworks. The stakeholder management was added a few years ago as the NINT knowledge area. So maybe for the engineers also, and that was my question, for the engineers, project management institutes framework, project management framework has a stakeholder management pillar. So, and it's very similar to your framework, maybe probably it's inspired by this framework. And there are some responses matrices, like when to respond to which kind of stakeholder with which influence. But I see that in this project management and engineering management frameworks, they are very closely related to risk management. Impact and probability matrices are widely used both for stakeholders management and risk management. And it's so engineering approach with a little bit reference to the social side and context, non-contextual in fact. So what do you think about these interpretations in the other disciplines about stakeholder management? I mean, is it that easily manageable with some matrices and templates? Thank you.
No, I think it depends very much on where you are and what kind of industry. I know I just got thinking about it, that I had discussion with some, entrepreneurs, or the engineering, big engineering consulting companies and so on. And one of their problems was that, everything is a new project. So it's easier kind of maybe to make some type of stakeholder management when you, let's say, have a production or so on. You produce a product like mobile phones and so on. But if you are building a bridge in Turkey, or if you are kind of doing a new railroad in somewhere else, you know, you have a new group of stakeholders every time. Maybe also have a different type of project. So it requires a special type of stakeholder kind of engagement. I think some of the models can be kind of done in the same way, but I think the fundamental difference is that you have a new set of stakeholders for new project, and you cannot always choose them yourself. I mean, a lot of these companies, they have to use, you know, the local whatever product, or they have to, you know, collaborate with the local government, and they have to. I mean, they cannot choose their their stakeholders in any possible way, which gives a lot of problems for a lot of these engineering companies. So, whereas it may be a little more easy if you just, you know, I don't know what, selling tomato soup or something like that. It's a different game. Yeah.
So thank you very much for your wonderful presentation. I was wondering if in your study regarding stakeholder engagement and how organization can also impact in a positive way stakeholders, you also try to focus on the role that narrative and rhetoric can have on not just on the dark side of greenwashing side of trying to depict reality in a different way, but also on fostering spillover effects on stakeholders. Because basically I'm researching this topic from a corporate purpose perspective, so it's not focused on sustainability but more on ethical issues. But looking at the rhetorical aspects can be also interesting and innovative way. I was wondering if you had the chance to deepen this kind of topic. Thank you.
I think it's very relevant, and also because, as we probably know, I mean, different groups of people talk in different ways. Maybe also academics, they have their own little community, and when we talk to somebody in business and so on, we have to adapt, or kind of getting accused of being impossible to understand and so on. So the rhetoric and how you engage with stakeholders is highly important, and even simple things can maybe be turn-offs for certain stakeholder groups. Previously, I did some research on lean management, and I was always told when I had to talk to public customers that you should never mention lean, because just that word itself is just, there's no way they will talk to you. I mean, because there are certain words that triggers, you know, all types of resistance among certain groups, whereas we could go to any private company and say the same thing, and then it was fine and so on. So the way you talk about things and interact, I think is clearly important. There are some scholars who actually looked at the kind of rhetoric and stakeholder and how you talk. I'm just thinking also the communication scholars. My previous center manager, Mette Morsing, is kind of quite famous for again stakeholder communication, and have this model of different types of stakeholder communication. The problem I sometimes have is that, again, communication comes with costs. I mean, and there's a tendency that you should always just talk more with people, and it doesn't really sometimes make sense in the sense that you can always do more, and that there's always a potential criticism of companies because they could have always have talked more with or involved them more and so on, but it's not so easy in practice, I think. But definitely important. Yeah. Anyone else? Otherwise, you are free to reach out to me or Heinek, then you can forward it to to me afterwards. So, yeah.
So thank you very much for this inspiring presentation. It was amazing that it looks like you already know everything, so there's nothing much more to do on the topic. Yeah.
There's plenty more.
I was expecting something like, impressive, but I had no words to describe the level of knowledge that you already have developed on the topic. So thank you very much. This is your house. Wherever you want, you are welcome here to visit us. And thank you very much. Thank you. And also, because we are closing the activity now, I would like to say thank you to the school for letting us to make the activity today and yesterday. And also, I'm not expert in introducing speakers, as you can see. But I'm expert in saying thank you. Thank you for coming. Yeah.